Assalamu alaikum students, welcome back to another class. Myself Zain Javed Mughal, your chemistry teacher. So in this lecture today, we are going to learn about chapter number 3, that is organic chemistry. So in the classroom, we have gone through the characteristics, general characteristics of the organic compounds. Then afterwards, we will study the representation of organic compounds, and we discuss in the representation the molecular formula, structural formula, their condensed formula, and dot and cross formula. These all are the formulas that are represented, used to represent the organic compounds. And then afterwards, we have gone to the topic classification of organic compounds, in which we study the different classifications of organic compounds on the basis of open chain compounds and cyclic compounds and their sub branches. Okay, so now the next topic that we are going to study today is diversity and magnitude of organic compound. So there are some examples, just like a DNA. The DNA molecule in a human being cell or in a chromosomes are basically composed of organic compounds. The methane gas, I have told you in the classroom that the methane gas is the gas that is known as Marshall gas or the natural gas, and these gases allows our stoves in the kitchen to be burned. And then the benzene is an organic compound that is used as an organic solvent for the solubility of non-polar organic compounds. And this is another structure of organic compound. So the topic that we are going to study in this class is diversity and magnitude of organic compounds. Okay, so there are total of 118 elements that are currently known. More than 10 million organic compounds, carbon compound exists. Yes, now class, as we discussed in the 9th class, that we have in a periodic table is almost 120 or 118 elements currently. But if we talk about the organic compounds, those compounds which contain carbon element as a backbone, so we have more than 10 million organic compounds. While in periodic table, there is only 118 elements. And in carbon compounds, we have a number 10 million, more than 10 million. So what are the basic reasons? What are the qualities of a carbon that it exists or it makes or produce more than 10 million different compounds? Maybe there are some features, and obvious they have. So in this class, we are going to study about the diversity, that why the carbon is so diverse in making the organic compound, why there is 10 million compounds that are organic in nature, what are these properties of carbon that allow it to make a large number of organic compounds. So the following factors contribute to the existence of such a great number of organic compounds. For example, number one is the catenation, and the number two is isomerism. Number three is carbon's covalent bond strength, and number four is multiple bonding. Now we are going to study one by one everyone. So the number one is catenation. What is catenation? So the ability of the carbon atoms to join with another via covalent bond to create a long chain or ring of carbon atoms is the primary cause in the formation of vast number of organic compounds. Yes, catenation is the ability of what? Carbon atoms. Catenation is the ability of the carbon atoms to join with another carbon atom via covalent bond. Yes, in the catenation process, one carbon atoms bind with another carbon atoms, forming a covalent bond. Then the second carbon atoms again binds with the another kind of carbon atom via covalent bond. Then the long chain is formed of between carbon atoms, or sometimes this chain becomes closed and forms a ring-like structure. So the catenation is a property or ability of a carbon atoms to join with each other via the covalent bond, forming the create long chains or forming the ring structure. So the first property that is the primary cause for the formation of the vast number of organic compounds is the catenation. Not all the elements have the power of catenation, but the carbon has a very large power or ability of catenation. Therefore, it forms or exists in different forms of organic compounds in nature. So straight or branch chains are possible. Yes, we have two types of chain. Either it will be a straight chain or it will be a branch chain. Now the next, Catenation is the capacity of an atom to build long chains and huge rings by linking with other similar atoms. यस, व्हाट इज बेसिकली कैटिनेशन? कैटिनेशन एक वो प्रॉपर्टी है किसी भी एक एलिमेंट की जो उसको उसी की तरह के सेम एलिमेंट से कंबाइन करे और बनाए, या तो लॉन्ग चेन्स बनाए या तो हमारे पास ह्यूज रिंग स्ट्रक्चर्स बनाए। तो ये प्रॉपर्टी हमारे पास क्या कहलाती है? एक दूसरे से बॉन्ड बनाने की, सिमिलर एटम की कैटिनेशन कहलाती है। अब हमारे पास दो मेन क्राइटेरियाज हैं जो कि कैटिनेशन को फॉलो करने होते हैं, यानी हमारे पास वो एलिमेंट्स हमारे पास कैटिनेशन कर सकते हैं जिनके पास दो क्राइटेरियाज हैं, दो हमारे पास बेसिस हो। The number one is the element should have a valency of 2 or more. Yes, जो भी हमारे पास एलिमेंट होगा उसकी वैलेंसी 2 या 2 से ज्यादा होनी चाहिए। It must be have a valency of 2 or more than 2. And in case of carbon, we have a valency of plus minus 4, as we have gone through the first lecture in the organic chemistry. And we deal with the valency of carbon dioxide, and we have found that the carbon has a valency of plus minus 4. So this properties or this criteria followed by the carbon. Second property or criteria is an element's bond with its own atoms should be stronger than the element's bond with other atoms, particularly oxygen. Yes, the second property is if the one element that forms or have a capability of catenation when combines or make a bond with the similar atoms of itself, so the bond should be stronger. It mustn't be weak, it must be stronger than the bond with the other atoms. For example, if the carbon-carbon bond is stronger than carbon and oxygen bond, so this means that the carbon can cause or form a catenation, can form a long chain of carbon atoms, can form a huge rings. The property is what? The element's bond with its own atom should be stronger than the element's bond with other atoms. For example, like carbon and oxygen. So here is the some structure that carbon formed through the catenation. So the catenation is the self-linking property of an atom, that is the ability of an atom to form bonds with other atoms. That I have foretold you. So the first we are seeing in the slide is that the straight chain carbon atom. This is the straight chain carbon atoms. You can see here that the carbon is bonded with another carbon, then third carbon, fourth, fifth, sixth. And all these carbons are bonded via covalent bond. Okay, via covalent bond. These are covalent bond. Now the second structure here is branch chain structure. The branch means a single carbon compound or a carbon is attached to any of the carbon in a chain. It means just it seems like a branch comes out of a tree stem. Okay, this is stem, this is the base, and this is the branch. Okay, so straight chain of carbon, branch chain of carbon, this also forms due to the property of catenation of carbon, and there is a bond that is representing the covalent bond. Now the branch chain of carbon, another example, we have there is a base compound and we have two branches here. The one is this and the other one is this. And this, in the previous case, we have only one branch, but in the next case, in this case, we have the two branches, number one and number two. Now moving towards the another compound, the carbon formed due to the catenation property is the cyclic compound. You can see here that all the carbon compounds are arranged in such a manner that it forms a closed chain structure in the form of cyclic chain. This is basically already a chain, but it is a closed chain. It means that it forms a cyclic chain. You know that why we are calling it cyclic, because it is a circular chain that is bonded and closely packed. You can see here the carbon and carbon are bonded through the covalent bond. Here also the covalent bond, and all the carbons are bonded towards each other by the help of covalent bonds. So these are basically the properties of the carbon to form different structures in organic chemistry, that some structures are a straight chain and some of are the branch chain, and the other one is the cyclic chain. And these all structures are due to the property of catenation of carbon compound. Okay. Now moving towards the next slide. Now the second property that is the cause of a vast number of organic compound is isomerism. Okay. So what basically the isomerism is, the phenomena of isomerism is another cause for abundance of organic molecules, as I have foretold you. If two compounds have the same molecular formula but distinct atomic structure in their molecules or different structural forms are said to be isomers. Yes. What is basically the isomers? If we have a two compounds and both the compounds have the same molecular structure, molecular formula. If we have two compounds and these two compounds have the same molecular formula but different structural arrangement, but different atomic arrangement, then we call that molecule as isomers. For example, the isomerism increase the number of structure that may be expressed. For example, the chemical formula for pentane. The pentane, the formula having a formula of C5H12. It has a three isomers. Pentane has a three isomer. The first one is N-pentane. Here you can see N-pentane. N means the straight chain. N means straight chain isomer. This is the straight chain isomer of pentane. Isopentenes mean the carbon has a one branch structure. Carbon has one branch. It means that this is isopentane isomer of pentane. And new pentane means we have two carbon branch chains, two branch chains in it, and this is known as new pentane. So here we can see that the pentane C5H12 an organic compound, alkane organic compound, have three isomers. All have the same formula. Here you can see we have 1, 2, 3, 4, 5 carbon. In this we have 1, 2, 3, 4, 5 carbon. And this also we have 1, 2, 3, 4, 5 carbon. All have the same number of carbon atoms. All have the same number of hydrogen, that is 12. But the structures are different. It means that those compounds which have the same molecular formula but different structural arrangement are called as isomers of that compound. It means that these all three compounds are the isomers of pentane. Again, we can say them that 1, 2, and 3. These all three compounds are the isomers of pentane. Got my point, students? Moving towards the next slide, the third reason that is a primary cause for the manufacturing or the production or formation of the vast number of organic compound is carbon covalent bond strength. So, as we discussed in the catenation, that the bond must be stronger between the carbon atoms. It means that the covalent bond must be have a nature of strong covalent bond. So because of its tiny size, carbon can make extremely strong covalent bonds with other carbon atoms like hydrogen, oxygen, nitrogen, and halogens. This allows it to make a vast number of different compounds. Yes, the carbon has a very tiny size. As we discussed in class 9, chapter number 3, periodic table, atomic size. The carbon has a very tiny size. And due to this size, and it can form easily the strong covalent bond with the other carbon atoms, as well as you can see in some cases we have bonded carbon with the hydrogen. We have seen the carbon and hydrogen bonded together. And in some cases, we can see carbon and oxygen bonded together covalently. And carbon is to nitrogen, and carbon-carbon bond, and carbon-carbon triple bond. This is carbon-carbon double bond. You can see that there is double bond and there is triple bond. So what are basically halogens? And also with the halogens are those compounds which are of group 7A in the periodic table. For example, like chlorine, bromine, iodine, astatine, and all these are called as halogens because they form halo. Halo means salt, so they form salt compounds. Therefore, the carbon have a very strong covalent bond with their itself, with carbon-carbon atoms, with nitrogen, oxygen, hydrogen, as well as with halogen. So this is the third reason that may cause possible, that may make a possible vast number of different organic compounds. Now moving towards the next slide. The fourth reason, the fourth cause that produces a vast number of organic compounds is the multiple bonding. Carbon may form multiple bonds in order to meet its tetravalency, that is double and triple bond. Yes, as I have foretold you in the classroom that the carbon has a valency, yes class, plus minus 4. This is carbon. It has 4 bonds left. 1, 2, 3, and 4. This is basically the structure of carbon, and carbon have a tendency to form four covalent bonds with the other compounds, other elements. This increase the number of structure that can be built. For example, here we can see that this all are accommodated by H, hydrogen. This forms methane. If we replaces the hydrogen with any other compound like chlorine, it forms another compound, it forms chloroform. Then if we replaces it with N or sometimes oxygen or any other element, so the new element will be formed. So this is the basically the property of multi-bonding of carbon that make it possible for the formation of a large number of organic compounds in our nature. So you can see here a single covalent bond connects two carbon in ethane. This is the structure of ethane, and in this structure you can easily see that the carbon carbon have a single bond in between, and this single bond is formed in the formation of ethane. Now moving towards the next, we have a double covalent bond connects two carbon atoms in ethylene. Ethylene is the structure that have two double bonds between the carbon carbon atom. In ethane, we have seen that there is a single carbon atom. In ethylene, we have two carbon at two double bond, two bonds in the carbon atom, and two single lines is known as double covalent bond. Here is a single covalent bond, and here is a double covalent bond. Now, the triple covalent bond connects two carbons in acetylene, and now this is the structure of acetylene in which the triple bond is formed between the carbon-carbon atom, and this triple bond is formed in the structure of acetylene. So here we can see that carbon can make multiple bonding. Either it will be the single bond, it will be the double bond, it will be the triple bond. Single bond is can be seen in the formation of ethane, and the double bond is seen in ethylene, and in acetylene we can see the triple bond between the carbon-carbon atoms. So these are the basically properties that we have discussed. That the number one is the catenation, number second is the isomerism, third one is the carbon's covalent bond strength, and the fourth one is multiple bonding. These all four are the properties or factors that contribute to the existence of such a great number of organic compounds that we have discussed, that more than 10 million organic compounds exist in a nature, and these all four are the properties of the carbon atom that make it possible to form a vast number of organic compounds in the organic chemistry. And so class, I hope so that you have understood all the factors that are the basic factors for the existence of such a large number of organic compounds. So if you have any question regarding any of the factor and any of the property or any other question, you can ask me in the classroom, and inshallah I will clear your all the confusions and all the questions. Hope you are and doing well, and inshallah we will meet you in the next class. So goodbye all of you.